Unfortunately, my Beko washing machine has stopped working. I've had it for 15 years. In that time, it has gone wrong extremely rarely, 5 times. 3 of those times were due to service issues. For instance, a little piece of paper or a coin has got stuck in the drain motor. One of those was caused by my stupidity, where I walked into the door and smashed the door handle, and only one of those occasions was actually caused by an actual fault with the machine, which was the noise suppressor blew up. All of those things being simple to replace, and this Beko washing machine has actually been very, very good. Very simple, as you can imagine. It's 15-year-old technology. Very good condition. There's no rust on it. There's, nothing looks bad. So I'm a bit gutted, actually. Hopefully this is something fixable, and this is an opportunity to take a look at the internals of a washing machine and see if we can work out what's gone wrong. It was turning. Unfortunately, the drain motor has stopped, although I can hear it whining as though it wants to do something. There's been a few clicks which shows the relays working, but the program appears to be turning. If I show you, this thing here is the selector, and it's got a little motor in it. If you advance the selector, so for instance, and I switch it on, you can see that it's recognising that, and it's advancing the selector. Fortunately, that's a drain motor. This stops at the moment. Let's put it on there. Oops, let's not put it on there. Let's put it there. So that would tell me that the computer's still working and something's wrong with the electronics to the motor, the drain motor, and the motor which turns the actual drum itself. It's full of water, it's got stuff in it. It's a case of now I've got to get the water out and see if I can work out what's wrong. The first thing that I'm going to do is I'm just going to switch it off, and I'm going to see whether it drains. Switch back on again. Now it has been draining. There was a kind of like a woof sound, and then I didn't really pay a great deal of attention to it, but nothing, no further sound thereafter. Let's see what we can do. So good, it's draining, which is a good sign. It's always positive. That means that it's been recognised that it's in that position. This is the only hardwired part. I believe these are software switches. It's computer controlled, and it fills the water and sort of goes through its procedure, but it hasn't spun out. It hasn't even lightly wrung it. Try and take all this stuff out, because the first thing I need to do is remove the items that are on there. So I have to wait. The door latch unlatches. That's the noise of the door latch. So I can now remove the items, or the item which has broke my machine. Let's take that away to start with. So the next thing I need to do is to get the water out of the drain, and to do that there's an access down there. You need something to open it with. Generally what I'm going to use is a coin. Let's do the first one. So you just usually need to turn it through 90 degrees, and I'll use this very same thing to access the water. So you just unscrew this thing. So let's get it started. That's maybe a little bit too much on the first go. See if I can get that into this bucket. There we go. Okay, so that's the sump that's emptied, and obviously one of the very important things to do whenever you start mucking about with the machine is to make sure it's switched off. So, right, so that's the sump emptied. So now I can move the machine into a more reasonable position where I can access it better. This is the main isolator to the washing machine. I've switched that off, and the isolator goes down to a socket which is behind the machine, usually not easily accessible, although this one is accessible. I've switched those into the off position. This is an extender. This is actually to an extension that goes somewhere else. I needed that temporarily, which is why I've got this Poundland 3-way extender in here rather than just using the washing machine on that, and then this particular thing, which is part of my one of these Voodoo type questionable whether or not it works descalers. But the important thing down here is that this is my mains feed into the kitchen area. I have the cold and the hot, which you can see there, and these are ball valves. That is a tap valve. This is what you expect on a stock cot. They're much more reliable. And then you have the ball valves. And one of the things that I certainly recommend if ever you have a ball valve is to make sure that you turn it either fully on or fully off, and you always test them every 6 months, preferably minimum once a year, because often you'll find, certainly if you live in a hard water area, they can be seized. The process of actually turning it loosens it and unseizes it. So fully on or fully off. And in this case they're both on. You can tell because they're kind of like in line with the pipe, and to turn it off I just turn it in those directions so it's perpendicular to the pipe, and then thus showing it's off. I've just isolated that for the water just in case something happens. I don't end up with a massive fountain of water. So here's the top of the machine. I've emptied it of water. I've moved it into a position where it's easy to access, and although I haven't disconnected for water, I have disconnected it from the mains physically, so the plug has been removed from the socket. And now I'm going to, just for mental completeness, I'm going to switch off at the switch, even though it's not necessary. I'm going to do it anyway. So I'll need to remove the 2 screws at the back to allow me to slide the top off. That's good. Okay, that's the first strap. Put that there. I'll pick that up in a moment. To get the top off, you really need to just pull it backwards and it will come away. So I'll just look inside there. You'll see that there's been a bit of a spider fest. It's absolutely full of webs. You'll notice here that there is a mark which looks like soot. Now, on this is the thing that exploded beforehand, which is the suppressor. It's not critical to the machine, but it is critical to stop noise going down your mains. You can see some charring on this, but I know that this is good because I replaced it like for like. But that charring there is around where the PCB is. So let me put this somewhere sensible where it's not going to fall down. That's an interesting little machine. This thing here is the tray that fills with water. It's got 2 solenoid valves, or the proper name for these that nobody ever calls them is a pilot control valve. So 2 pilot control valves there, run by solenoids. Here, this is the rotary switch, which is powered by a motor, and there's some wires coming off it. I'm not entirely sure what they do, but I'll soon find out. We've got the main PCB here, and we've got the pressure switch here. This is the suppressor, this thing here, that's the suppressor. We have a hose that goes from here. This plastic thing here is the main drum, which is suspended. I think there's 2 or 3 springs, I'm not sure. I think there's, looks like only, yeah, 3 springs. There's 1, 2 and 3 there. And there's some shock absorbers underneath this. I heard the clicking, which sounds like it's from the PCB. There's also charring, or what looked like some charring that happened around that. The motor for this is definitely going, because I saw it rotating. The first thing I'm going to do is actually just take out this PCB, which should be hopefully relatively easy. Those are always the famous last words, aren't they? Whenever you remove connectors like this, these things, you should always hold it by the connector and hold it by the PCB. Never grab it by the wires. These are, they look, yeah, they're IDC type wires, which means that they're pushed in and there's a knife in there which cuts into it. And if you pull it by the wire, you're liable to actually pull the wire out, which will be a disaster in its own right, and you need the cylindrical thing to push down, but you've got to be careful to get the right tool really to do these properly. But you don't need to do that if you take the connectors off properly. Let's remove this one, bottom. I think I'll find that, don't they? So there's a release for the PCB here, and that turns that way, so let's pull it out. And, oh, that's rather unfussy, isn't it? It's quite nice. So I'm going to pull the connector, and what I'm doing is I'm just easing the connector off. It's quite stiff, this one, but I'm only holding it by the connector and holding the PCB, by the edges, not by components or anything like that. Here's the actual main circuit board. There is the brains of it, which is no doubt a microcontroller. That's the other side. And these are the relays. Let's take a quick look and see whether or not there's anything obvious that's burnt. Ah, look at that. That's burnt. There. This relay here looks like it's got hot, or at least on that leg. Now I had some clicking which suggests that one of them at least is working. I would say this one. Just as a guess, I would say that likelihood is that these relays are used to swap the polarity essentially between the live or one phase and another phase, or you could say live and neutral, but if, say for instance, you didn't have live and neutral, as far as it's concerned it's just a line in and a line out. I suppose the best thing to do is really take a better look at this under some good light. I'll test that relay. Most of the other stuff seems to be working on it, or at least I believe it to be. There might be something wrong with the motor, so I'll check the motor, but I'm going to check the PCB first to see whether it's something obvious. It could be something's wrong with the motor which has caused the damage to the PCB, but we'll not know until I looked at that a little harder. We have spiders. There's an awful lot of spiders. There's also whatever the spiders are eating. Sometimes what happens is one of those things gets into the PCB, or a spider spins a web and somehow that becomes conductive due to maybe oil or whatever that's around in the air, and it can cause problems with circuits. Sometimes all you need to do is vacuum it. Just blow it with air or get a duster on it and it will just burst back into life. But in this particular case, I don't think so. Just something I don't know if it's clear here. There's a little patch of stuff right here, and that's oil from when the original one of these exploded. It's a pi filter, they call a pi filter, a parallel inline filter. It's got an inductor, capacitors and so forth inside there, and it's all filled with oil. And the oil popped out. It could be electrolyte, for all I know, part of the capacitor part of it, but whatever it was, it all ended up here. Although I can see stuff here, it's not that. Obviously this is powered down. You never put your hands near things like this which has open live parts, like so. These solenoids will run directly off 240 volts. Back here, I can hear, you can't see this, but I'm actually turning the rotor which rotates the, and you hear that noise. Do you hear that high pitch? That's because it's spinning the motor below it. So that's not seized, that's spinning freely. That tells me that there's nothing wrong with the bearings on this. So it could be the brushes, it could be, most likely it is the circuit board, or the circuit board as well as something else. So again, I'll check that now. Right, okay, so let's take a look at the board and take a little bit closer look at this and see if we can ascertain what actually happened. Let's just change the lighting slightly, see whether we can get more preferential lighting on this. So looking at this, If you look at these relays here, and these relays go into this, so this is the burnt out thing that we saw. Now there was a load of what looked like carbonization or some sort of dark coloured burning looking stuff, which was rather unusual, but I know that these relays, that this is common, and those are the normally closed and normally open. And I think that's the normally closed part, that's the normally open, and these two parts here are the winding which actually throws it. So that would be the stator part, and these would be connected to the armature, and these are commoned together. So looking at the other side of this, my belief is that the motor, two rotors, R1 and R2 are those two, and the stators, S1 and S2, are those two. It seems quite logical, and the tacho is the thing that basically measures the rotational speed, either sending a pulse or some other form allowing it to measure or work out the speed. So looking at the back, bearing in mind that those two there, it looks like that the rotor part of it is fixed, and the other side of this, which is those pins, which are the other side of the relay, sorry, those ones, they go to the stators. So it looks like the stator has been switched over by the relay between these two. The rotors are basically the same, so they're not switched over. It's the stator which is switched over, which is unusual. I would have thought it would be the other way around, but it doesn't really matter. As long as the polarity between the two is changed, the motor will reverse direction. That gives us a clue that if that is the stators and rotors, we can just take a look at those from the edge connector and see whether or not we've got a short or an open circuit or something like that from those particular connectors. So let's go and look at that now. So over here, I'm just going to use this as a reference, so I know that from this polarizing edge, this sort of point that stabilizes where the connector goes on, that 2 in are the stator, the edge connector, and we shall look at that. I'll stick it on resistance to start with, and so these I would expect to be connected together, stator 1 and stator 2, and that's showing as basically 1 ohm, yeah, 1.1 ohms. Between the stator 2 and R2 I should have no connection, because basically these shouldn't be connected together, it should be open circuit. And between the two rotors, rotor 1 and rotor 2, again I should have a low reading, which I have there. I'm going to rotate the drum, which will spin the motor, and see whether or not that actually makes any changes. Yes, it does. This is measuring the resistance, and it works by sending it through a current and then working out, depending on what the current and voltage is, the resistance of this resistor. When I throw this, it's throwing that out. It's just making a change. It doesn't really tell me what that change is. I'm going to go to the two stators and see if the same thing happens. 1.1. The same thing happens there. It's generating a small current when I rotate those things. That shows it's not a dead short. Something is actually happening there. Let's go to the tacho. Tacho is reading something. Let's just change multimeter. Let's see whether or not the Rishi is going to give us a little bit more interest in the reading as far as this is concerned. Put it onto Hertz. Now, if this is resistive, it's not really going to do anything, but if it actually generates a current, then we should be able to read something. So let's see. So that tells me the tacho's reading back. That is probably from the motor. As the brushes wear down, they flick off little bits of carbon, and that's carbon build-up. That's probably from the brushes. So I'm fairly confident that that motor is actually quite good. The only thing that looks bad on this is the relays, and in actual fact it's the contacts on the relays which look bad. Now, I'm not going to desolder them right now because The worst that you can do is connect two together for one of the stators, which means that it will be the same voltage and no current. Essentially that will mean that the motor isn't going to rotate, but you shouldn't burn anything out by doing that. Let's just check. I don't think I've checked that yet, which is the two motors of the relay, the windings themselves are okay. So we'll take a look at that. Now I heard them clicking, so I know at least one of them is okay. So if I compare one to the other and they're the same or greatly the same, then I would say that probably the relays, the motor's okay, but it doesn't mean that the armature might not be seized. So we'll take a look at that now. I don't know if I've gone through this already, but I shall go through it again nonetheless. The edge connectors here, S1 and S2 are for the stators of the motor, and R1 and R2 are for the rotors of the motor. Tachograph is on the motor, but I'm not interested in those because the problem looks like it's with the relays, these particular connectors. I don't know if it's clear that you can see, if I can focus in. So you can see one is burnt out, but you can see the others don't look exactly brilliant either. So one of these is normally open, normally closed. I think this is normally closed and that's normally open. That's the common between the two. And these two here are the windings. There should be no connection. And I put that onto the resistance. On this side, you can see that there's two diodes, which are flyback diodes, I believe, and they're put onto the two windings. Let's do a few checks to start with. So I don't expect to have any connection from the winding to any of these at all. Well, it's high. That's the other side of the winding, which essentially is the motor part or the stator of the relay. Let's do the other one. Check that. Let me check. Right, so 1.3, 1.3. So pretty much symmetrical. Let's do it the other way around, just to see whether that changes or not. Yep, it's exactly the same, pretty much. One of these, should be the normally open contact. No, it's normally closed contact, and that one should be the normally open. That's pretty much normally open. Again, this is normally closed, and if I go to the outer part of the through-hole plate, see it's not connected. If I go to the pin itself, it is connected. If I go to that, which is also normally open. So I'm confident that there's going to be no feedback from these connections. They're independent, and this might be stuck, but it doesn't really matter in this case because it's only switching the stators and the rotors are fixed, essentially a fixed connection. Because of the nature of these four connections, which is normally open and normally closed on each of these, I'm going to unsolder those and resolder. I'm not going to take the whole relay off. I'm just going to unsolder and resolder those particular connections. Got this. I'm going to use this. I'm not going to use desolder braid. Now, unfortunately, I lost the sponge. I don't know where I put it. So I'm going to use this sponge. And hopefully that should be melted, which it is. And let's just... So for this, let's start with this. Now the reason why I'm doing it like this, so adding the solder, is because it just makes a better contact. So this is the horrible one. So let's do that. Resolder this. And then unsolder it. It's okay. Interestingly, this board isn't conformal coated, so those have come away nicely. So you can see that those are all free. So I'm now going to resolder these. This one has clearly got very hard. So let's resolder these. So they look, well, that looks a bit questionable. Let's do that again. It might be that we've got intermetrics on that. It needs to be cleaned better. So I'm going to get some solder braid for that. I'm just going to use a bit of solder braid on this to clear down as much of the solder as I can on this. The reason is, if there are intermetallics on there, which is basically where the solder mixes with the copper and it forms a new alloy, that alloy just seems to constantly cause dry joints and bad connections and high resistance. So I'm going to do that again and resolder. That looks substantially better. So now I'm going to have to look for my flux cleaner. I don't have it to hand, so let's see if I can find some. The reason why I'm removing the flux is because it's always good practice, full stop. Unfortunately, I can't find my flux cleaner. I'm just going to use this stuff. I pray. This is actually acetone. Most of this flux is IPA soluble. Unfortunately, I can't find my IPA either. If this was conformally coated, acetone would be the thing that you would remove the conformal coating with. But for some reason they're not conformally coated this, which is quite strange considering it's something that has moisture and that around it. So let's just clean that as best I can. Let's look at that connection again. If you don't clean the flux off, the flux is activated by heat. So anytime it gets warm or hot, which it may do because of those contacts, it will reactivate the flux and start eating away at the circuit board. Don't want that to happen, so remove the flux. If this was conformally coated, you would reapply nail varnish, which is the clear lacquer, to put back the conformal coating. So it's basically what conformal coating is. It's a cellulose coat, pretty much, nail varnish. Okay, that looks good to me. We're going to have a go and see whether or not this has solved the problem. Oh, that doesn't look like it's taken off the flux there. Let's try that again. Okay, so there you go. Let's put this back. So here I am back at the machine. I've got the board, which is being newly soldered. So I just put new solder on there because I don't believe that there really is anything much wrong with this, other than the fact that those connections are burnt out. Let's put this back in. When you put something back in, because of the nature of these connections, they're knife connections, that you must hold it by the connector, not by the wire. The first key way, so that little slot, there's a little slot on this to make sure it all lines. Again, when you're touching these things, make sure you only hold it by the edge of the circuit board, not by any of the components. So I'm going to put this in to this thing here and snap it back in. That's good. Okay, next connection. So again, that's one in. It's so simple, you know, just one board, tiny little board. This is the actual motor which turns the rotor, and they're using this for actually switching more heavy duty current, like for the heater. Maybe I shall go through that another day and take a look, see what that is, but at this moment I really want to get some washing done. Let's put this on, make sure that goes home. So everything looks like it's gone in. Really, it's now time for testing. In a perfect world, I'd be able to pat test this. I would always pat test something like this first, but I don't have a pat tester, so I can't. I'm just going to consider that what I've done here is so trivial that it's not worthy of a pat test. Of course it is worthy of a pat test, but since it's my machine and I want to get it running, then I'm going to take that leap of faith. It's always a dangerous leap of faith to take. I've got the plug here, and let's plug it in. So plugged it in, switched on at the wall outlet, switched on at the isolator, hands away from anything dangerous. The first thing I'm going to do is just check to see whether the drain function works. So just put it on drain, and this was working before. Let's see. So no flames, that's always good. Look at that. It's going both ways now. So you can hear the relays click as it swaps over the polarity between the stator and the rotor, which allows it to turn the opposite direction. I am going to put my item back in. No, I'm going to put the lid back on and push it back to where it should be, and then we'll start this off. So let me switch this off before it goes off into crazy mode. Spin. Do a quick spin to start with and stop. And there's a very light spin. Strange noise coming from it. Maybe the bearing is starting to go. See the strange, it should be in balance, so I'm surprised that it is. There's nothing in it, so it should be in balance, but go. So the washing machine appears to be working, so that's good. I shall now put my item back in and see if I can spin it off. Okay, thank you for watching.